Adding fractions. The basics with adding fractions is that you need denominators that are the same. If you don't have denominators that are the same, then you can't add them together. Okay? It means you've got to find them, and we'll do that next. So here we've got 1/3 plus 1/3. Now, what is interesting with this is often with these questions, if you say the words out aloud, rather than saying 1/3 or 1/3 plus 1/3, you say 1/3 plus 1/3 equals 2/3, and most people understand that without actually having to have it taught to them. Okay. What we see from this is that the denominators, they don't add them. It's only the numerators that get added, 1 plus 1, okay? And think about it along the lines of 1 apple plus 1 apple is 2 apples, okay? So the thirds here are represented by apples, okay? In that they are a thing, okay? They're thirds, they're not a number of items. Okay, let's look at a question now where potentially we've got different denominators. We can't add thirds and fourths or quarters, okay? So we need to find a common denominator. So we need a number that both numbers go into. So here, 3 and 4 both go into 12, okay? So we need to find common denominators that'll give us 12, okay? And what do we multiply 3 by to get to 12 is 4. And what we do to the bottom, we do to the top. And by 3 times 4 to get to 12. So what we do to the bottom, we do to the top, okay? Importantly, you need to put these little notations on your work that indicates what you're doing, okay? And helps us to track your progress through a question. So 3 times 4 is 12, 1 times 4 is 4, 4 times 3 is 12, 1 times 3 is 3. So now we have 4 twelfths plus 3 twelfths equals 7 twelfths, okay? Okay, let's have a look. Now we've got one where we've got a whole number and a fraction, okay? Now, common sense tells you that 8 plus 3/4 is 8 plus 3/4. And that's true, that makes sense. Let's look at how it works mathematically, which, just to show you how it does work, but I wouldn't recommend you doing it this way. It's just a proof. All right, so 8 is 8 over 1, okay? So that's a whole number as a fraction plus 3/4, okay? And we want common denominators, so the common denominator here would be 4, so we can leave that one as it is. So that's times by 4 becomes 32 over 4 equals 35 over 4, and then we go 4 and 35 goes 8 times and 3 left over 8 3/4, okay? So that's the proof, okay? But for this type of question, I wouldn't bother doing all of that to prove it, okay? I would simply go from there to there in order to answer that, okay? Let's look now at some mixed numbers, okay? So let's look at, say, for example, 2 and 3/4 plus 3 and 1/3, okay? Now, we don't need to turn these into improper fractions to solve them. Some people will, okay? And often that can be an easy way because they understand it, but in actual fact, you can just treat this as 2 plus 3, okay, so that's going to give us 5, and treat that as plus 3/4 plus 1/3, okay? And just work out that section of it, okay? And as we've seen previously, the common denominator for 3 and 4 is 12, okay? Okay? So we've got 9 twelfths plus 4 twelfths, okay? And so we end up with 5 plus 9 twelfths plus 4 twelfths is going to equal for us 5. And here 9 and 4 is 13 twelfths. And we end up with an improper fraction here, so we need to turn that into a mixed number. So 12 goes into 13 once, we add that onto the 5, give us 6, with 1 left over. 6 and 1/12.